thing is that we covered on Friday, which was SOHCAHTOA. Remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then the cosecant is the reciprocal, hypotenuse over opposite, secant, hypotenuse over adjacent, and cotangent, adjacent over opposite. Then the reference we talked about was the 30, 60, 90, and the 45, 45, 90 triangles. We said that if they're in that circle, or if the radius is 1, then these are our values. 45 opposite the 45s, because there'd be 1 at the top too, would be 1, and opposite the 90 is your root 2. And then if it had a radius of 1, the 30, 60, 90, opposite the 30 is the 1, opposite the 60 is root 3, and opposite the 90 is 2. Today we're going to talk a little bit about what happens if this is not a radius of 1, and that's when it would be x, x, and x root 2, or a root 2. People use a 2. Actually, yeah. And then opposite the 30 would be x, opposite the 60 would be x root 3, and opposite the 90 would be 2x. So again, that's if your radius is different than 1. So we're going to talk about reference angles. And a reference angle is the acute angle. That's the distance between the angle given and the x-axis. So you'll be given an angle, and it will ask you to find the reference angle. And then based on that, we're going to find some trig functions, okay? But we start with just what is the reference angle. So because it has to be, it actually can be 90 degrees. So it can be less than or equal to 90 degrees. Because that's the case, anything in the first quadrant, the reference angle is the same. So if I ask you for the reference angle of 30 degrees, it's 30 degrees. 47 degrees, it's 47 degrees. 89 degrees, it's 89 degrees. The moment you get bigger than 90 degrees and you've crossed into that second quadrant, you find the reference angle by doing 180 minus that angle. So if I ask for the reference angle for 100 degrees, you would do 180 minus 100, and my reference angle would be 80 degrees. So again, if it's in the second quadrant, we do 180 minus the angle. If it's in the third quadrant, we do the angle minus 180 degrees. So if I said something like 200, then my reference angle would be 200 minus 180, and it would be 20 degrees. It has to be 90 or less than 90. So if it's bigger than 90, you know you've done something wrong. And then in the fourth quadrant, it's 360 minus that angle. So if I asked for the reference angle of 300 degrees, I would do 360 minus 300, and I'd get 60 degrees. So if you're building a reference sheet for your test, I would say that this little graphic, or somehow writing that out, is a good thing to add to your test. It won't be on your quiz, but it would be a good thing to add to your test, okay? It's always the distance between the angle and the x-axis. Remember that this is 0, this is 90, this is 180, this is 270, and then this doubles back around to 360. So that should help you kind of locate where the angle is. All right, so this one just says find the given value. So the first thing we're going to do is figure out the reference angle. So I'm going to say step 1, find the reference angle. 2, find the trig value of that reference angle. 3, determine plus or minus based on original angles quadrant.
Natalie said she's in the waiting.
I can't let her in. Tell her I'm sorry.
She said she was in the bathroom.
Tell her I'm sorry, but I already marked her absent. All right, so 210 degrees. Where is this located? Third quadrant. It'd be somewhere over here. Yes, third quadrant, 210 degrees. So if I want to find the distance from 210 to 180, I just have to do 210 minus 180. And I get what? What's 210 minus 180?
Wait, why'd you do 180?
Because I want to find the distance between that angle and the x-axis. So at that point, it's 180. Yeah. It's 30 degrees, yes? Yes? Yeah? Okay. Well, turn the brains on, folks. 30 degrees, right? That's my reference angle. So, in order to find the sine of 30 degrees, I'm going to build a 30, 60, 90 triangle. Now this we are assuming has the radius of 1. So this would be 1, root 3, and 2. What's the sine of 30 degrees?
1/2.
1/2. Opposite over hypotenuse, yes? Now we have the value of the trig function. Next we have to figure out the positive negative sign based on where the original angle lies. So if my original angle is in that third quadrant and all students take calculus, what's the positive or negative sign of sine in the third quadrant? It's negative, right? We're going down, so the y would be negative, right? So this is actually a negative 1/2. So this angle is in the third quadrant, right? Which means I move back and down. Sine would be the down, so it would be negative. The only thing that's positive in the third quadrant is tangent. That's what the T is for. And cotangent. It's a reciprocal function. Yeah.
I'm kind of confused like what you subtract.
So wherever, go back to like for me, in the first, right, theta equals theta prime is how we show reference angle. Those are equal. Second quadrant, I have to do 180 minus theta. Third quadrant, it's theta minus 180. Fourth quadrant, it's 360 minus theta. It's always got to be between 0 and 90. So if it's too big or too little, you know you did something wrong. You're welcome. But the definition of the reference angle is the distance between that angle and the x-axis. So if I went from here all the way around to 210, right? I really just want to know what this value is here. So it would be 210 minus 180. That's where that comes from. But for me, I just remember that what's there in the black. Like if you wanted to add that onto a little reference sheet, that would probably be a good idea. And then add the all students to calculus. All right, so 7. Tangent of 300. Where does 300 lie? Fourth quadrant. So I'm going to do 360 minus 300, 60 degrees. Now I have a 30, 60, 90 triangle, but I want the angle that I use to be the 60. Opposite 30 is still 1. Opposite 60 is still root 3. Opposite 90 is still 2. And tangent is which two letters? Opposite over adjacent. So what's opposite 60 degrees? Root 3. What's adjacent? 1. So root 3 over 1 means it's just square root 3. Then, because now we got to figure out the positive negative sign. Where did this original angle lie? Quadrant 4. Is tangent positive or negative in quadrant 4? Negative. So this is going to be a negative square root 3.
So is the final answer just negative square root 3?
Yep. Correct. On Canvas, when you get a question like this, you would type that in as negative SQRT 3. So for those of you that are taking this at home, oh, we're delayed already. Those of you taking that at home, that's how you type it in. Like that. Questions on that one? Okay. Tangent 675. Well, that's fun. That's not in first, second, third, or fourth quadrant. That's too big, right? What can I do with that? That gets it in between 0 and 360. God bless you. Coterminal. Subtract 360 from this. and I get 315 degrees. Is that between 0 and 360? Yes. So now I can say, okay, 315 would be where? Fourth quadrant again. So I'm going to do 360 minus 315 to get my reference angle, which is 45 degrees.
So when it's not in the first, second, third, or fourth quadrant, you always have to subtract.
Coterminal, yep. And if it was really negative, I'd do the opposite. I'd add it, yep. Now, I want my 45, 45, 90 triangle. So on a reference sheet for a quiz or test, I would certainly add those two. Opposite the 45s are 1s, opposite the 90 is root 2. So if I want tangent of 45, it doesn't matter which one I pick. Let's just say I pick the bottom left one. What's opposite 45? 1. What's adjacent to 45? So 1 over 1 gives me 1. My tangent is 1. Now I got to figure out the positive negative sign of it. So where's that original angle lie? Quadrant 4. What's the sign on tangent in quadrant 4? Negative. So my answer here is negative 1.
How did you choose the 45, 45, 90?
Because my reference angle is 45. So once I got a coterminal that was in my 0 to 360, I find the reference angle, and that tells me which of the special right triangles to use.
Wait, why isn't it positive?
Because it's in the fourth quadrant. So in the fourth quadrant for tangent, we move forward, but we move down, right?
But isn't it like 45 degrees?
45 is just the reference angle. The actual angle itself is in the fourth quadrant.
So the reference angle is just what you just need the triangle?
Correct.
What happens if it's not 60, 45, or 30?
In order to do these questions without a calculator, it has to be. It has to either be 30, 60, or 45, or 90, or 0.
So what's the reference angle?
This reference angle is 45, because we did 360 minus 315.
So it has 45 in the fourth.
45 is not in the fourth quadrant. The actual angle's in the fourth quadrant. So we get 45, that's the reference angle. We build the triangle, and then the location of the original angles in the fourth quadrant. That tells us the positive or negative sign. Reference angle will always be positive. Good question. Reference angle is always between 0 and 90, so it's always positive. Okay. Negative 240. Where's this angle? Go backwards, right? Negative 90, negative 180, negative 270, that's too far, which means second quadrant, right? How do I find second quadrant? Usually I do 180 minus. Is that going to work this time when it's negative? No, it's going to be too big, right? So how could I find it if it's in that second quadrant, but it's negative? Think about what would be.
240 minus 180.
So I would do, like, you're trying to find the distance between negative 180 technically and negative 240, right? So I can either do negative 280 minus a negative 240 or 240 minus 180. Either way, I'm finding the distance between 180 and 240. Does that make sense? Distance is absolute value, so we don't really have to worry too much about the signs here. The signs gets us our location, but the actual reference angle is just the distance between 240 and 180. So I can do 240 minus 180. 60 degrees. So if it's negative, really find the location based on the negative angle, but then to find the reference angle, pretend as though it's positive. It's the same answer. Okay, so we're back to 30, 60, 90 triangle. Whoa. 30, 60, 90 triangle. 30, 60, 90. Opposite of 30 is 1. 60 is root 3. 90 is 2. So if I'm looking at the angle that's 60 degrees and I want the cosine, what's my answer?
1 over 2.
Good. 1/2. Adjacent is 1. Hypotenuse is 2. Now I need positive or negative. So this angle, the negative 240 is in that second quadrant. What's true about the cosine in the second quadrant? It's negative, right? Because we move left and cosine would be the x value. So it's negative 1/2. Say again? Because you're in the second quadrant. So in the second quadrant, the only thing that's positive is sine, and then its reciprocal function. So cosine's negative. Does that make sense? So the reference angles is a small bank that I could ask for. 30, 60, 90, 45, 0. That's it. That's all you're going to get given. You have to know all the trig functions of all 5 of those, right? But then outside of that, the actual original angle, that's where it's kind of like an endless amount of possibilities. When you find the reference angle on these questions, and this would be on next Wednesday's part when you don't have a calculator, that reference angle has to be between 0 and 90 degrees. And without a calculator, it has to be 30, 45, 60 if you're gonna draw a triangle from it, okay? So think that limits the amount that you could pull from, right? It's the original positive or negative sign that would be the difference, okay? Wherever that original one is located is going to change. Questions on these? So again, once you find your reference angle, if it's based on a question like these and you don't have a calculator, that reference angle has to be 30, 45, or 60. And then you find your triangles from there, and you can find your trig functions from there. All right, now we've got reciprocal functions, right? So for 10, I'm going to find what and then flip it? Cosine. So I'm going to treat this as though I'm looking for cosine of 210, and then in the end, just flip it. How about 11? Tan of 135, and then flip it at the end. 12. Sine of 210, and then flip it at the end. And then so I want you to do 10, 11, and 12. And then I'll do 13 and 14 with you, but do 10, 11, and 12. All right, so 210 is located in which quadrant? Third quadrant, right? What would be the reference angle for 210? 30 degrees. The cosine at 30 degrees, so I'm going to draw myself a triangle, 30, 60. This is 1, root 3, 2. What's the cosine of 30 degrees? Nope. Root 3 over 2, right? Because this is a adjacent over hypotenuse. So I know that's the value. Now I got to figure out the positive, negative. That because it's in the third quadrant, cosine is what? Negative. This is negative root 3 over 2. Yep. Now I have to flip it, right? Now I've got to go secant, which actually I shouldn't have circled it. Let me go back. I need secant, right? So secant is the reciprocal of this. So I flip it. Negative 2 over root 3. Can I leave it like that? No, I rationalize it by multiplying by the square root of 3 in the top and the bottom. And I get negative 2 root 3 over 3. On a Canvas quiz, so if you're in person, you'll write that like right on the line. But on a Canvas quiz, if you're at home, you will type that in as negative 2 SQRT for square root 3 divided by 3. That would be the format of a fill-in-the-blank question, okay? So just keep that in mind. Like as you kind of answer these questions, you can practice them as what they would be on Canvas. All right, let's go straight to 12 because guess what? Same angle, right? 210, but this time I want the sine. So I can still use this triangle. What would be the sine at 30 degrees? 1 over 2. Is sine positive or negative in the third quadrant? Negative. It's negative, so it would be a negative 1/2 for sine. And then because it's cosecant, we would flip it in the end, and it'd be negative 2. All right, go to 11, and I get the tangent at 135, and then I'm going to flip it at the end. 135 is in which quadrant? Second quadrant. So I do 180 minus 135, and I get 45 degrees. I use my 45, 45, 90 triangle, which is 1, 1, and root 2. Pick either angle, so let's say it's here. Tangent is 1 over 1, so my tangent at 135, or tangent at 45 is 1. And then if it's in the second quadrant, is tangent positive or negative? Negative. Flip -1, it's still -1. Okay, then I get to 13, -510. This is too big, right? So I can go back by adding 360. I can find my positive coterminal by adding 360 here. So I could do -510 plus 360, that's -150. That means I'm going from here around past the 90, but haven't hit the 180. That would be a -150. If the negatives throw you, feel free to add 360 to that sucker again and get a positive. It doesn't matter. So if I take that -150 and I add 360 to it, I get 210. It's the same angle. Does that make sense? Okay, so if you rather make it positive, I could use -150, or I could add 360 to it and get a positive 210. Either way, I know that angle is in this third quadrant. The reference angle, the distance between it and the x-axis would be 30 degrees. So I'm finding the sine at 30 degrees. Go back to my triangle up here because we already have it. And the sine is opposite over hypotenuse, which would be 1/2. I'm in the third quadrant, so is this positive or negative? Negative. So if the negatives throw you, feel free to keep going coterminal until it becomes positive. You'll get the same answer. So speaking of, -1020. Add 360 to it. I'm at -660. Add 360 to it. I'm at -300. Add 360 to it. You could use it as -300, absolutely. Yep. But if you want to keep going positive, you could keep going until it is positive. So now I'm finding the tangent of 60 degrees. So 60 degrees is its own reference angle. It's in the first quadrant. I use that 30, 60, 90 triangle, but this time I'm focusing on the 60, which was at the top. Tangent is opposite, which is root 3, over adjacent, which is 1. My tangent is root 3. And the coterminal angle means it's the same location, which means that -1020 would be in the first quadrant, and my answer stays positive. So the reciprocal ones, you want to remember to flip at the end. You could also do use the triangle and do hypotenuse over opposite if you don't want to remember to flip it at the end. You could keep it as secant. Questions on those? Yeah.
So when it's the positive and negative things, just say it's in the second quadrant, would cosecant also be positive?
So if all students take calculus, this is what's positive, right? Of my initial 3 trig functions. So this is really that sine and cosecant are positive and everything else is negative. Tangent and cotangent are positive and everything else is negative. And cosine and secant are positive and everything else is negative.
So when you're doing the ones where you have to flip it, it doesn't matter which you use to find determine negative and positive, right?
Say that again?
You can look at the cosecant or the...
Correct. Correct. Yep, it doesn't matter if you use its function or its reciprocal function to figure out the positive or negative. Correct. All right, so now we're going to flip-flop this. Finding the angle when given the trig function. So all those examples, I asked you for the trig function of the angle. Now, I'm actually going to give you the answer, and you have to give me the angle. So you're finding theta over the interval of 0 to 360, unless it says otherwise. Sometimes it says 90, but we'll talk about that when you get there. So let's just say it says the cosine of theta is -√2 over 2. First of all, how do I get square root 2 over 2? Is it gonna be a 45, 45, 90 triangle? Or is it gonna be a 30, 60, 90 triangle? 45, 45, right? This one is 1 root 3 and 2. The only time I have a root 2 is in my 45. Does that make sense?
So that's because it's a root 2 in the answer that it's 45, 45.
Yep. If there's a root 3, it's the 30, 60.
So if it was a root 2 or if it was like a 1, then you would be 45, 45.
Yeah, for me, what I would probably do if I was you guys is learn the sine of 45, the cosine of 45, the tangent of 45 based on this triangle. And then I would learn the sine of 30, the cosine of 30, the tangent of 30. And then I would learn the sine of 60, the cosine of 60, and the tangent of 60.
So if we didn't learn that, how would we know, like?
You'd have to figure out each time. You'd have to go back to your triangle each time. So it just takes extra time. Yeah. I would know as soon as you see a square root 2, it's a 45. As soon as you see square root 3, it's a 30, 60. If it's a half, 30, 60. If it's a 1, 45. So sine here, we would say it's 1 over root 2, right? Which is the same thing as root 2 over root 2. Root 2 over 2, sorry. Cosine would be 1 over root 2, which is the same thing as root 2 over 2. And tangent is 1 over 1, so it would be 1. Then go to my 30, 60, 90 triangle. Sine of 30 would be 1 over root 3. No, sorry, 1 over 2. Cosine would be root 3 over 2. And tangent would be 1 over root 3, which becomes root 3 over 3.
Why do we do both triangles if we know it's 45, 45?
So my recommendation is you learn both triangles to help you with this kind of question. If I was just focusing on this question, I wouldn't need the second one. But I would learn both because you're going to get more than just this question.
Wait, for the sine of 45, why is it root 2 over 2?
Because it'd be 1 over root 2, and then you'd have to rationalize it. Does that make sense? Okay. And then remember, sine and cosine switch for the 30 and the 60, which means the sine of 60 is the same as the cosine of 30. And the cosine of 60 is the same as the sine of 30. And then the tangent of 60 is the reciprocal of root 3 over 3, which would be root 3. So it's important to understand how to get these, but it's also to your advantage to learn those 9 trig functions. So because I'm looking at negative root 2 over 2, focus first on the root 2 over 2, right? Which angle gives me a cosine of root 2 over 2? 45 degrees. But it's negative. So now think about my circle. Where is cosine negative? Quadrant, say it again. Quadrant 2 and 3 is where cosine is negative, right? So what would be my reference angle, what would be the original angle if my reference angle is 45 in the second quadrant? How would I reverse that?
45 plus 180.
Close.
Oh,
It's less than 180, right?
yeah.
So it would be 180 minus 45. So that angle is 135. And then we said it also would be in the third quadrant. So it would be 45 bigger than the 180. So these are the 2 angles, and almost every single time there will be 2 answers to these questions. There will be 2 options between 0 and 360 that have that trig value.
How did you know to add it?
So I know that there's 2 places. Once I figure out the reference angle is 45, right? I know I'm going to either add or subtract 45 from something. Now I got to figure out what quadrants it would lie in. So cosine is negative in the second quadrant, and it's negative in the third quadrant. So how do I get an angle that would have a 45-degree reference angle in the second quadrant? So I want this angle if this is 45. That means I have to go 45 less than 180.
Oh.
Does that make sense? And then I need to do it again, but I need it to be in the third quadrant, so I'm going past 180, 45 degrees.
Okay, so like.
It's the reverse of what we did before.
So if the angle was like 300, or just say it was like.
So if it was 300, your reference angle is going to be 60 degrees.
Okay, so then like the fourth quadrant, would you add or subtract?
So if it was, let's say this was a positive root 2 over 2, then my answer is going to be 45, because that's its original angle, right? Because it would be positive. And then in the fourth quadrant, it would be 360 minus 45. We'll do some more examples, but that's the idea. Figure out what quadrant it lies in, and then based on where it is, if you're on the left-hand side, you're going to add and subtract your reference angle. If you're on the right-hand side, from 180. On the right-hand side, you do it to 360. Yeah.
You said that sometimes it'll say from 90 to 360.
No, it'll say 0 to 90.
Or,
And then you would only give the original reference angle, that's like the 45.
so it's just telling us like if it's like 45, 45, like 360.
Right.
360.
Right.
If it's a 0 to 90.
If it's 0 to 90, then you're only given one answer, and it's the reference angle. Yeah. All right, let's see how many of these we can get through in 6 minutes. All right. So I'm going to draw, this is what we just did. We did the sine of 45, we did the cosine of 45, we did the tangent of 45. Then we did the sine of 30, the cosine of 30, the tangent of 30. Then we did the sine of 60, the cosine of 60, and the tangent of 60. So we just wrote this out. I'm just going to rewrite it out again so it's right here for us. Root 2 over 2, root 2 over 2, that's the same. 1, this is 30 is 1 half, root 3 over 2, root 3, and root 3 over 2, 1 half, root 3 over 3. Nope, this is over 3, sorry, and this one's not. Okay, so look first at the value, then worry about the sign. If cosine is root 3 over 2, what's my reference angle? 30 degrees. Now, where on my circle would cosine be negative? Second and third quadrants. So if I take the 180 and I subtract 130 from it, what do I get? If I take the 180 and I go less than 30 degrees, so I subtract 30 degrees, 150. And if I get that 30 degrees and I add it to the 180, 210. Go to 16. Where is tangent root 3? 60 degrees. Where is tangent negative? Why can't I get the letters right? All students take calculus. 2 and 4. So in 2, I need to subtract 60 from 180. 120. And in 4, I need to subtract 60 from 360.
Oh, so are you basically doing like
The opposite of what we did.
The reverse of the reference angle. So if it was in the second quadrant before, we did 180 minus it, right? So you're actually doing the same thing. Yep. All right, go to 18 first, and then I'll go back to 17. 18, where is tangent root 3 over 3? 30 degrees. Where is tangent positive? 3 and 1. So 30 degrees is one of my answers, because that's what it would be in the first quadrant. And then 180 plus 30 degrees, 210. Depends on which quadrant it's in. If it's in the second quadrant, we're going to subtract it from 180. If it's in the third quadrant, we're going to add it to 180. That the original reference angle is 30 degrees because tangent is root 3 over 3 at 30 degrees. And then tangent's positive in the first quadrant, so we keep the reference angle the same in the first quadrant.
What's it in the fourth?
Say again?
In the fourth, you add.
In the fourth, you do 360 minus it.
And, when it's square root 3, how do you know to put, 30, not 60?
60 it'd be just root 3. 30 it's root 3 over 3. Okay, so now we get cosecant. So what do I want to do with it? It's reciprocal, so it would be sine. If I flip 2 root 3 over 3, I get 3 over 2 root 3. What would I have to do with that? Rationalize it. 3 root 3 over 2 times 3, which is root 3 over 2. If when you're messing around with these functions, you get something other than 1/2, 1 root 3 over, like one of our initial trig values, then you did something wrong in your work. So just pay attention. It has to be one of these 9 values. All right, so this says plus or minus, which means that this is going to happen where? Where are they positive or negative? In all of them, right? All 4 quadrants this time. So where is sine root 3 over 2? 60 degrees. So it'd be 60 degrees from my first quadrant. Then as I move into the second quadrant, it'd be 180 minus 60. So 120. As I move into the third quadrant, it'd be 180 plus 60. 240. As I move into the third quadrant, it'd be 360 minus 60. 300. So it's all 4 spots.
So do the plus and minus.
It's going to be 4. Questions? All right. Homework is due tomorrow morning. If you started it, great. There won't be too much. If you didn't start it, you get your little hands full tonight. Okay? And then tomorrow we'll go over that. We'll talk about what's on your quiz. And we're going to do a little bit of calculator work tomorrow. So make sure you've got a scientific calculator with you tomorrow, or graphing, actually. It doesn't matter. Have a fantastic day, folks. You're welcome. Bye, ladies. Have a great day.
You too.
Thanks, Katrine.